Hello, everyone. Sorry, I already talked to you for a while, but I forgot to press go to live. So my apologize. It's our first time doing these workshops. Today I'm gonna teach you for more advanced practices in data engineering and software engineering. And I want to split this honor to teach you guys with my amazing colleague, Hiba. Hiba, welcome to the stage. And let me tell you briefly what we're gonna learn today. So, agenda. First, we gonna learn how to customize your incremental loading. And then we will remember how to configure your schema and learn about data contracts. Next, we will play again with tracing and learn a bit about logging, how it works with DLT pipelines. Then Hiba will tell you about built-in DLT request wrapper and retries, which you can easily apply for your pipelines. Then I will tell you about performance optimization, how to boost your pipelines easily. And after that, we will try to build custom sources using REST API helpers. And then we're gonna learn what is reverse ETL and how to build your own custom destination. At the end, we will play with deployment. We will try to run DLT pipeline on Lambda function. We'll try to orchestrate it with Dagster and Airflow. And as a bonus, Hiba will tell you about dbt runner. So, Hiba, please, you can start. How to stop sharing? Oh my God.
All right. Hello, everyone. I hope you guys can hear me. If you can't, please let us know. I am working with Aliona. I've been working at DLT Hub for the last year, almost year. And before that, I've had like a bunch of data roles, data science, data and research, data analyst, business analyst, and a lot of startups. So yeah, I think that's enough about me. Let's just start off with our first topic, which is custom incremental loading. Right, so I hope you guys can see it. And once again, if you can't, please let us know. So incremental loading, if you were at our old workshop, I hope you were, just as a refresher, it is the act of loading only new or changed data and not old records that we've already loaded. It enables low latency and low data cost transfer. Another refresher, we have three write dispositions or methods of loading data in DLT. We have append, replace, and merge, and then we have different strategies to merge. In this notebook, we will be focusing on different ways of customizing your incremental loading. And before that, it's pretty important to know a few terms. The most important one is a cursor field. I'm sure some of you already know what that is. For those of you who don't, a cursor field is a specific field in your data that is used to track and that's basically used to track your changes, see when your data was loaded. For example, in this particular resource that we have been working with and we will be working with throughout this workshop, we have the get issues resource, and the cursor field here is basically the updated at field. And in this notebook, we will be using the created at field as the cursor field. So once again, we start with our example that we will build on. We have pagination, and we will use that to extract all of the issues from our GitHub API. and we'll be using the cursor field created at. Right, so we have a pipeline declared, and the first thing that we do is the simplest. We run the pipeline with an initial value. So what this initial value will basically do is tell your URL here that's being sent to GitHub that you want your initial value to be, the first place that you load the data from. And if we look into the data that has been loaded, we will see that our initial value, being the 1st of January 2024, is exactly what is in the data in the created at field. Data is till today, the latest data, and the first one is from the 2nd of January. So yeah. Now, once again, the cursor field or the last loaded value is pretty important. As we've seen, it is basically the point in time in which we can know where to start the next load of data, or just we can keep track of the last one. Within DLT, we have several ways to define and track this cursor field in our pipeline. We can store the largest value, which means the latest created at, and we can use the smallest value, which is the earliest created at. And this is achieved through the last value func parameter, which you can see it's right here. Once again, this is just a resource definition. We have the get issues, and in the updated at cursor field, we have the last value func as max. This is, once again, this is the default method inside DLT. You pick the last value where you loaded, which makes a lot of sense because you want to know when to start the next load from. But you can also specify that you want the minimum value or the earliest value as well. You can customize this with the last value func parameter, and we can see how that function works, and we will work on that towards the end of the notebook just to save time. Yeah, I added a logger here so that you guys can see in the notebook what values are being compared, where the last value is being stored. How it basically works is per value that is being, per row that is being streamed into your pipeline, your cursor value is first and foremost in the very first row, compared with an initial value, which you can define, and we have defined it. And then in every successive row, that initial value kind of gets replaced with the last value, which is the minimum of the cursor value and the last value. I hope that makes sense. In a nutshell, this will basically, as all basic programming problems go, you can recognize that this process will have your lowest value be stored inside the last value variable, right? So yeah, I'm just gonna skip over this one and then move on to see the results, right? So we ran the pipeline and we saw that going back into time with the cursor field, we loaded data from 2022. If you remember, we just had data from this year, but with this, we went back in time and just backfilled our data. And as I said, I added a logger to this, and the last value stored in this logger is also the minimum value in our data set for the created at field. Yeah, I hope that makes sense. Moving on, there is another way you can backfill your data, which is very straightforward. And I'll be defining another pipeline for this because I don't want to mess up what we have going on. Here we have the initial value and the end value to define that we just want data from the latter half of 2023. So the initial value is July of 2023, and the end value is the 1st of January in 2024, which again is just data from the second half of 2023. And because we defined this, the load is exactly what we would expect. Once again, loading the data from the created at field, we see that the maximum value is towards the end of 2023, and the minimum value is in July 2023. You can use this to either backfill your data or just to load your data in chunks. So again, different ways of incremental loading. You can optimize this method with the initial and end values with the row order. It's just, again, another method to optimize your backfill. With the row order argument, DLT will stop getting data from the data source if it detects that the values of that cursor field are out of range with the start and end values. This can be pretty useful if you are loading any sort of data that does not particularly have an end value. You can just define your row order for this. And yeah. And now that we've seen the different parameters of DLT sources incremental, we can go back to the pipeline state. If you were there in the last workshop, you probably might remember, or if you don't, the pipeline state is basically a Python dictionary which lives alongside your data, and you can store values in it, and in the next pipeline run, you can request them back. Now, if we look at what we have in the state right now, we can read it. It is stored somewhere in your pipeline, and you can access it through a bunch of keys. And the date that we have stored here is exactly the date that was the least minimum value that we stored in our very first pipeline, no, the second pipeline run. So yeah, that date got saved, and it's pretty useful because you can request this back for your next load, which is basically the point of having a cursor field at all. So how will we access this? It will basically be through this, right? So I define another resource here called get issues with state. And what I do is get the last value, which is exactly from the state, get created at from a bunch of different keys. And I use that to send the GitHub request this time. And since it was 2022 June, I believe, yeah, 2022 June is the minimum date in our created at, and the maximum is of today. So now that we know what the last value func is, which is your custom function to define how to get your cursor field, and now we've also seen how we use the pipeline state to get your cursor fields, we now can write a custom function for looking back into your data in the next pipeline run. How we do that is basically, it's the same methodology that we used right here, but instead of having just this as the cursor value, it's the cursor value minus 1 month. So what you would assume, and instead of min, it would be max, but you would assume what comes out of this process is the maximum value minus 1 month. Let's look at the data here. Oops, sorry, the code here. Right, the new last value is your item that is being passed in every single run, and then the last value that you've gotten from your pipeline state. And if we look at the data here, you see that the data is exactly as it was, and the only thing is that the pipeline state value has now changed to 2024 July. And what's the difference between this? This is exactly 1 month earlier than the maximum value inside of your data. So when you run the pipeline again with this, you can know that this is, the last place that you loaded. Yeah, this was inside the log file. This is inside the pipeline state. So yeah, these are the methodologies with which you can customize your incremental loading. Moving on. So we then move on to schema configuration and data contracts. Yeah. So DLT offers many different ways to be able to control your schema and then define it. And this gives you control over data processing. It gives you the power to be able to control what's going into your data, databases. And yeah, let's see how that is. So a refresher, understanding schema. So whenever you run a DLT pipeline, DLT generates a schema file, and you can export this file to a specific location in YAML. This is what that looks like. There are a lot of different headings here. We won't go through all of them. You can, if you want to, in the documentation and also in this collab, but we will be covering the most important parts of this. So as you can see, first off, there's a version hash here, which every time you change the schema, your version hash changes, and you can basically keep track of whatever changes are being done to your schema. Right, then you have a particular way of naming your tables, and that naming convention is very strictly followed thanks to DLT. There are a lot of particular things that setting a particular naming convention can do, like adds an underscore if the name starts with a number. And I think the most important one is this one, that during the normalization process in your pipeline run, you have the parent-child relationship between tables, and that is expressed as double underscores in names. So yeah, there's that. And then let's move on to like the more fun bits.
Wait, they can't see your notebook.
Oh, can you see it now?
Should we do this?
Is it fine? Okay. Oh no. Anyway, okay, I'll go through this. Yeah. Well, going back, I just talked about what the schema file looks like, and this is what it actually looks like. And also, thank you for pointing out that you can't see it. Yeah, we talked about the version hash and how each version hash keeps track of the changes that are in your schema. And this previous hashes can tell you what changes or how many changes have been done to your schema. We have particular naming conventions, which take care of how your tables and columns are named. It has particular functions that it takes care of, the most important one being during the normalization process of your DLT pipeline run, you have parent-child relationships, which are expressed as double underscores, and a whole bunch of different things. And now, this is where we were talking. So we talk about tables and columns. So we see a table schema has a lot of different properties. There is name, description, parent columns, right disposition. We know what all of these things mean. Description is, I think, the most underused one. It's the one where you want to fill in the documentation, but it's just very tiring. Then we have the column schema, where you have, again, name, description, data type, and a lot of different things that we will go over. Then the column schema can also have basic hints, which is basically telling you if a column is nullable, it's a primary key, a foreign key, etc. And also it can have performance hints, like is a column used for partitioning, for clustering, or for sorting. Then, we have schema settings inside the schema file as well that has detections and default hints. Detections are basically used to infer the data type of a column value, which is pretty intuitive and, in my opinion, very cool. Like, for example, if you have an integer that's going pretty big, which you have a large integer, and it goes beyond the 64-bit limit, DLT can convert that into another data type on its own so that it can be handled. This can be done both through the schema file and in code. The same thing with column hints, where you can define the nullability, primary key, foreign key, etc. This can be done, again, in the schema file and also in the code. Right? And I think let's move on to the also fun parts, applying data types to resources. So for example, you are defining a resource like this. You give it a name, you have probably maybe a right disposition here, and then you can also tell which columns you want to look like what. For example, this one column, it's called my column, has a particular data type. You can tell if it's nullable or not. And in the other parts of resources or sources where you don't define them yourself, for example, this MongoDB source, which is dynamically generating resources, you can use the apply hints functionality to be able to apply hints to your columns. Right, so now that we've gone over applying hints and applying like preferable things, let's move on to like the more harsher things like contracts, and now you are making laws on what can and cannot be done on your data. So data contracts, for those of you who don't know, are rules to basically help control how your data schema changes over time, if you want it to change over time or not. And DLT has implementations of data contracts at various levels, the table, column, and data type levels. We will start with the table. So you have two basic specifications. You have evolve and you have freeze. Evolve basically allows the creation of new tables within the schema, and freeze does not. To pick up a basic example, we have this Python dictionary. We have ID and name. We have two users that we want to add to a table, which we did. We ingested it and it was fine. It was done. If we try and add a new table with the evolve schema contract, it's also done. We created another table with the same two users. It was all fine. However, if we try and create another table with freeze, you will not be able to, because DLT does not allow you to go ahead with an operation like that when you have the schema contract as freeze. Yeah, pretty useful. Then we move on to the column level. So in addition to evolve and freeze at this point, we also have discard row and discard value. Evolve, again, allows the addition of new columns. Freeze prevents changes to the existing columns. Discard row is something where if you add new columns, those rows will completely be rejected by the existing schema, whereas discard value keeps the new rows, but it just discards of the new columns that you add. Just to look at examples, we have another pipeline here with an ID and a name. This is just how we define the initial resource. And if we look into the data, we see the ID and name. Alice is there. She's happy. We now add another resource to the table name users. However, this time we add Bob with an H. This is another column that was not existing in the previous one. However, it's okay because we have the schema contract set as evolve. So it's done. Alice and Bob are there. Alice does not have an age and Bob does. Right. Now we have discard row. In discard row, as we discuss the functionality, we'll see that in action. We have ID, name, and age, which is good. It's being supported by our data so far. However, we also have a phone number now, which was not there before. But with the discard row schema contract, we see that when we add Sam and Kate, Kate unfortunately does not make it to our database because we have the schema contract as discard row. And because phone number was never there, the database says, I don't know you. Yeah. And to make it a little less strict, we try again. We add Sarah and Violetta, again with an age, name, and ID, but Violetta with a phone number. And we see that Violetta does make it into the database, even with a phone number. But yeah, the phone number itself does not make it to the database. And that is on column level data contracts. However, with the strictest way that there is to define a schema contract, you can freeze your columns, and then you will not be able to add a phone number because then it will give you a data validation error and you won't be able to run your pipeline there. Right, now we have the data type level, right? This is the last level that you have, again, with the same four that you had with the column level: evolve, freeze, discard row, and discard value. Evolve is The nicest one, it allows you any data type. However, this may result with variant columns, which we'll discuss in a minute what that is. Then there's freeze, which is the most unforgiving one. You will not be able to make any changes to the existing data types. Then you have discard row and discard value, omits the rows with unverifiable data types, and discard value replaces the unverifiable values with none, but it keeps the row. So let's start with another pipeline where we have ID, name, and age. So a 24-year-old Alice is inserted into our database, and she makes it there, and it's all good. Now, if we try and evolve the data type, if we remember, the age here was defined as an integer or a number, but here we're trying to define it as a string or text. But thanks to DLT, we will be able to do that just fine because the string will be validated and it will be stored as an integer. However, if you try and do something like this, where you're trying to insert Bob with the age 35 in text, you will get another variant column, which will exist like this. So you had age, now you have age underscore v underscore text, where you have none for the ones who don't have that data type, and then you have 35 existing as it should. Right. Then we have discard row. We have 35 here, a 35-year-old Sam, and we have a 70-year-old Kate. Let's see who makes it to the data. Kate unfortunately did not make it to our database, and that is because we have the discard row schema contract, and that wanted to get rid of the entire row with the conflict of data type that it had. Then we have discard value, and we are trying to insert a Sarah and Violetta inside the database. Sarah is a 23-year-old and Violetta is 28. And we see that both of them made it to our database, just that age is not defined for Violetta because she did not follow our schema contract, which was discard value. And as for the last one, we try and insert Lisa, age 40, into our database, and you get a data validation error again because you cannot change it no matter what. DLT will not allow you to make those changes. And to look at a real-life example here, let's look at the GitHub repository example. We are trying to load an issue, a particular one, which is 1708. And we run the pipeline, and we see that the pipeline ran fine. We have an issues table, and we have an issues assignees table that was normalized, and we have one row there. All is good. And now we want to add more issues to this database. And the schema contract here is the tables are frozen, which means you cannot add any more tables. The columns have discard value, and the data type has discard row. So we create this issues resource, you run the pipeline, and we get an error. And why was that? We were trying to add the issues labels table. However, it was frozen, and we can't do that. So to fix that, of course, we changed the schema contract from frozen to evolve. And now we run the pipeline again and run into an error again. And the reason for that is that DLT never got over the last load package where it got stuck in the extract phase. So in order to clear that out, you can refresh your pipeline state and then start again. And now you're running the exact same code that you were the last time, and it worked. We loaded 100 issues that we can see from the response inside the resource. And when we look into the table, we also have 100 rows there, which is pretty cool that we didn't discard any rows. And that basically means that the GitHub API is quite consistent with the data types. DLT also supports pedantic models, and you can learn more about that in the docs, and again, also in this notebook if you view it again. So yeah, that was it for schema configuration and data types. And now we move over to inspecting load packages, tracing with Sentry, logging, and retries. So for an introduction, in this notebook, we focus a little bit more on the pipeline metadata. Just to remind you, we've covered a little bit of this content before, so I will be skimming through it a little bit, and then we will cover some new stuff as well. So we have a resource set up. Once again, it is the issues resource in the GitHub API. And we run a pipeline, we get the issues, it gets loaded. We have two data sets, which is the GitHub data merge and GitHub data merge staging, because our write disposition is merged. So we have a staging environment as well. More importantly, we have a DLT loads table that we can look into and see information there as well. So we've already covered in the last workshop what a load package is. As a refresher, it basically just has some information about the jobs that were ran in your pipeline runs. For example, when it was started, when a pipeline run was started, you can focus on particular completed jobs. You can focus on load packages with IDs, and you can also focus on the load packages of failed jobs. Yeah, so far here, we're lucky enough to not have any failures. So yeah, let's try and introduce one. Sorry.
I started next section.
Off.
Oh. Yeah, it happened to me last time. So.
Yeah, thanks. I'm so sorry. Right, so load packages, right? We have the GitHub resource. We have a DLT loads table where we have information about the loads. Then we had a basic refresher of the jobs inside of a load package and the information that is stored in a load package, which is see when it was started, what jobs were completed, and which ones were failed. All right, so far we don't have any failures inside the pipeline, but we can introduce one. And that would basically be, we just went over schema configuration, and I added this particular dictionary into the pipeline. And what happened was that it failed with a message that there's a constraint issue, which is basically that it does not have an ID. And since we are going against a contract, this will not get loaded. And now we check the failed jobs and we see that something does indeed exist. So we have several ways to trace the last pipeline run. We can look at the last trace, which gives us information about we ran the pipeline twice. So this is the first load package, which ran fine. This is the second load package with one failed job. Then we can see different information about extract info, normalize, and last load. Yeah, you can get into this and the information that it contains, and you can use this information and put it back into your destination, because since you will only be able to trace your last pipeline run, if you update each trace into your database, you'll be able to see the status of each of them. And it has a bunch of information in it, for example, the transaction IDs, the pipeline name, whether or not it ran, it didn't. So the run field here is false. Then we have another way of doing this with Sentry. And you can enable this tracing through Sentry, which is another method of doing so other than putting it into your destination. So what is Sentry? Sentry is an open source error tracking and performance monitoring tool. It helps you to identify and trace and monitor issues that will show up on a dashboard for you. It is not a part of the DLT package, so you will have to install it separately, but you can enable it with DLT. So again, for those of you who don't know, Sentry needs to be initialized with a certain key or a DSN. And after you initialize it, you can just use it. How? For example, you make an error here. 1 divided by 0 will give you a 0 division error. And since Sentry is enabled and initialized, when this piece of code will run, Sentry captures this exception and sends it to your dashboard. And there you know exactly what happened here. It gives you a trace of that. You can click on it and then just know what happened. This is pretty useful, particularly when you have deployments in different places and you can't really see the logs all the time. So yeah, this sends your errors and exceptions to your dashboard. Within DLT, you can configure the DSN in your config.toml by just setting up your Sentry_DSN key. And alternatively, you can also use environment variables, which is what we will be doing because we are in the Colab environment and it's just much easier to use environment variables here. So we do that. We set the runtime Sentry DSN with our key, and then we introduce the same failure back into our pipeline, which is we want to add data which conflicts with the schema contract, and it tells us that we can't do that. So you see that it went through the code as it normally would. And what happened here is that when you go see your Sentry dashboard, this shows up inside of your dashboard as well with a particular message, right? You may not be able to tell exactly what's happening from this message, but if you open it and see the message that was sent to Sentry, you will see that job for issues XYZ failed, and the reason is a constraint error, that there is no issues.id. Right, so that is it for tracing. And once again, if you have any questions, I'm sure that people will be following up, Leona and Anun will be following up with you on the chat and in Slack. So logs and logging. So we would be, as a coding nation and society, completely lost without logs. Debugging any system would be pretty pointless without logs if you can't trace where errors and warnings are coming from. So what are these log levels, right? Logging has certain levels and categorizations. You have info, debug, warning, error, and critical. And as you can tell from their names, these are like different levels of severity. And for example, if you set the logging level to warning, then you...
For a moment.
Yeah.
Can you close the table of content? So make it a little bit bigger.
Is that okay?
Yeah.
Okay. Right. So yeah, if you set the logging level to warn, then you will not get the ones that are less severe, like info. Yeah. Now logging in DLT, right? So you can also set these logging levels inside of DLT. So the default level is set to warning. So you will only see these logs if there is some sort of a warning in your pipeline. Then you have critical and debug as well. Critical will disable logging. Debug should not be used in production. So yeah, how do we do that? How do we set this? You can do that in your config.toml file, and then also through environment variables, which again is what we'll be doing. So you set runtime log level to info, and yeah, then you basically attach your logger to DLT. You get logger DLT does exactly that. You set a logging level, which here we have done for info. And then all of your logs will go inside this lovely file. And now that we've set the logging level to info, we've set up the logger, and we run the pipeline, you see that we haven't really printed anything here, but you've got a bunch of logs here that say info. And it tells you about each and every single step that's going on because you have given it permission to do so. Yeah. And then you can also configure log guru in your DLT pipelines as well. There is information on how to do that in the docs and also in this particular collab, but we won't be getting into too much detail on that. But what I do want to show you is here we set the log level to warning. Before that, we had info. Now we've set it to warning. And now that we run this particular pipeline, we don't get any logs. When you run this, you will not get any logs. And that is basically because you've kind of disabled the info level of logging. So when you run this, you won't get anything. The last thing for logging here is that you can use logs to see progress. The only thing that you need to do for that is to add this particular argument inside your DLT pipeline, and you will be able to see each and every single step, extract, normalize, and load, and how much time it's taking. You will see that in real time. It is pretty cool. So now that we have gone through the load packages, different ways of tracing in Sentry, configuring logging in your pipelines, we will now move on to retrying whenever you run into failures. I will remember to share this tab this time. Okay. Amazing. Thank you. So first, we'll be going through the request wrapper because that is what we will be using to retry your API requests. Yeah. So an introduction. For most cases, we usually use the requests library in Python on its own, and it obviously serves our purposes, which is why we keep using it. But in order to enable some additional functionality within your pipelines, okay, better? Okay. In order to enable different functionality in your pipelines, you can add the request helper. And with this, you simply use the request library as you normally would. You give it a URL with your headers, and you get the response, right? Everything's normal so far and familiar so far. However, this retry has a couple of default configurations and rules. For example, your retries are limited to 5 times. So if you do something wrong, it'll be retried 5 times before it finally gives up on you and gives you an error. Then, if all retry attempts fail, the client raises a request exception like HTTP error or connection timeout. Then you also have another another rule, which is basically that you can only trigger these retries for status codes which are between the 500 and 429 range. Other than that, you can customize an output, and we will get to that, but yeah. So example usage, we have a basic logger here set up, and we try and request this particular URL, which you can see is perfectly misnamed as github, and you can see that it retries this 5 times because that is your default definition, and on the 6th time it fails. It gives you an error, max retry error, and a connection error, and then you're done. And you can customize these retry settings. For example, you can change your max attempts from 5 to 10. Let's see another example for this. Right. The environment variable here for request max attempts is 7 instead of 5, and the request backoff factor is 0.5. And as confrontational as that sounds, the backoff factor is basically the delay between different retries. So here it's set as 0.5. Right. So we have another logger set up here, and we try and hit this incorrectly named API again. And this time you see that it ran for 7 times instead of 5 before finally giving you a max retry error and then a connection error. So next, as we said, that DLT covers status codes between 429 and 500. If you want something other than that, then you can customize a client. And what that basically means is you are defining another client here, request.client, that will work for these particular status codes and with whatever other functionality you want to add to it. So if you look at an example, we have a client here that is going to work for status code 403, and which is basically a forbidden response. And we will remove any default retry connection related errors that there are in normal request clients. And now we will try and send a lot of requests to the GitHub API. GitHub API, by default, it allows 60 requests per minute before it finally gives you a rate limit. And here we will try and run it 70 times altogether to see what happens. And you can basically see that per attempt, there is a connection request. So it goes from attempt 1 to 60. And on the 61st attempt, because of the rate limit being exceeded, you can see that this is run 7 more times before finally giving you the client error. Now, coming back to our misnamed URL, we have a different error, which is 404, not found. Right. And when we send this request, it basically does not give you any retry options because 404 was never in the definition of the client that we declared here. If we did, it would probably add to the retries, but it won't here. If we want to add more customization into this, for example, if you want to read inside of the body of the JSON response, you can do that as well through a customizable function. We have retry if error key, which basically what we want is if the words not found are in the message of the response, or the words API rate limit exceeded is also there, then yeah, that we want to be retried there. So this time we define another client with, we have disabled status code retries, but we have our own customizable function with this condition. And now we will try and hit this endpoint, which is, not a normal endpoint for us. It says wrong endpoint. And this again is tried for 1, 2, 3, 4, 5, 6, 7 times before it finally throws you an error. And yeah. So after all of that customization, you can also use Tenacity to retry your pipeline steps. So Tenacity is a powerful Python library that provides configurable retry mechanisms. For example, you can, we start off with just defining another pipeline here called Quick Start, and we add Lisa, age 40, into the pipeline. And here we try and again try and fight with the Schema contract configuration and add the age as 40. And you see that it says that pipeline failed after retries using the Tenacity retry helpers. So yeah, that's a way that outside of DLT you can use the retries from Tenacity. And you can also decorate your functions with Tenacity helpers to be able to retry different error cases as well. So that is it for your inspecting of load packages, seeing where errors come from, and retrying on errors. And that was the last part of the workshop for me. Before I jump into the bonus section, which is the DPT runner demo. And this one is for people, hopefully like me, are interested in the transformation parts, in modeling data. This will be pretty useful to you using DLT's DBT runner. So the combination of DLT and DBT is pretty cool. So as you know, that DLT takes care of the extract and load part, DBT takes care of the transform part. So you have a very beautiful ETL or ELT pipeline running with DLT and DBT. So in order to make this work, we have a couple of steps that, again, you can find all of this code inside the DLT Hub Education repository. So yeah, let's just get started with it. First of all, you install DLT DuckDB if you haven't already done so. And you should also install DBT with DuckDB support with pip install dbt duckdb. First of all, you create the pipeline, which is our simple step. We will be using the GitHub issues. I have that right here inside ingestion. So we have the same pagination, we have the same endpoint we've been using, which is issues. And yeah, we run the pipeline, we get all of the issues that we want from GitHub, and we have it saved into our DuckDB destination. Next, this is an optional step that I added because I am nosy and I like looking into the data at every single step of the pipeline. So this is just a query.py file that I added here in case you want a CLI way to be able to query your DuckDB database. Yeah, so this is just for me to make sure that the data is actually there, and it is. So after you have your initial pipeline set up, you have your initial data set up, you can initiate the DBT project and get started for your transformations. So you can initiate your DBT project with the command dbt init with whatever project name that you want to. Here it's workshop demo. And after I run this line in CLI, this particular project file gets created from DBT, and we'll get to what's inside of it in a minute. So my goal here is to transform the data and add a master table. So what is initially inside of our data, let me see if I can, yeah. What's initially inside of our data is we have this issues table. It has a lot more columns, but for the sake of showing these connections, I just added a few of them. We have the DLT ID, then we have the DLT parent ID in issues assignees, and we have the DLT parent ID in issues labels. And this connects basically to every single issue inside the issues table. So that is what the original model looks like. What I want the master table to look like is to have all of these issues. I wanted to have information for each issue's assignees and labels as well. So this is what it will look like. And in order to have this set up, the first thing that we do is we define the schema inside models, inside a YAML file. So what we have here is a name. I want my master table to be called issues master, a basic description, the most underused part of usual documentation. Then we have columns, right? We have an ID, which is unique. Then we have all of the other things regarding issues. And then we have our foreign keys, foreign information about our assignees, and information about the label. So we've defined this in a YAML file. The next step would be to define it as a SQL model, and which is exactly what I've done here. So thanks to DLT, we have a parent-child relationship between issues assignees and the main issues table. We also have a parent-child relationship between the issues labels table and the main issues table. So using this, basically, I create this SQL model, and then after saving these files, the SQL file and the YAML file, I can come back and now I can run the dbt runner inside DLT. And how will we do that is pretty straightforward. We, first of all, if you want to, you can define a new data set, because we usually have a place where our raw data is coming, and then we have a place which is basically more of a production environment that you want your data analysts to see. So this is what I want, to create a separate data set called modeled issues. And for it, we first of all attach a virtual environment. For this particular pipeline, for this particular data set that we created, it's the same pipeline. And then we get the dbt runner. We define that with the pipeline that we created, with the path to your model. And this is optional. You can attach the virtual environment to this if you want or not. And directly, you can just execute dbt.runAll, and it will now get inside of your destination. And that's pretty much it for your bonus dbt DLT demo. And if you want to learn more about how you can take DLT and dbt into production, there is a link to a very cool article here by another one of our colleagues. And yeah, that is it from me.
Let's start with performance optimization. As you know, that DLT is just a Python library, and DLT pipelines is just a Python scripts. It means we can apply any best practices from Python to our DLT pipelines. To understand how we can do that, let's look at the behind the curtains and see how DLT works. How does DLT work? From the previous part, you can remember that it works in 3 steps: extract, normalize, and load. During the extract step, DLT fetches data from source system and write to local disk. During normalize step, it reads extracted data from local disk in first schema and also write to local disk. During the load step, DLT reads normalized data from local disk and ingest into destination system. Let's start from the beginning. Extract stage. What happens at the extract stage? I prepared these small illustrations to visualize the process, because it's quite a huge topic. It's difficult to understand. That's why I will try to explain it on a high level. And maybe later we will record the specific videos about specific things like performance or DBT, I don't know. So what happens at the extraction stage? We're receiving data from API, for example, or any other source. Then data is fetched and stored in memory buffer by one or multiple threads. When the buffer of a thread reaches its capacity, the data is written to an intermediary file. And the buffer is cleared for the next set of data items. If a size of a specified for intermediary files reaches this size, a new intermediary file is opened for further data. So it's quite difficult to understand that. So I'm reading the text, sorry for it. Long story short, data going to the thread pool, workers processing your data and store data in as a files. Usually it's just a list of JSONs or JSON-L format. Okay. How we can optimize this extraction step? We can control in-memory buffer size. Now, what is in-memory buffer size? It's how many items DLT will keep in memory before it goes to the file. It writes in the file. So we can set really high buffer size. So it means that more items will be stored in one file, and it means that less files will be created. If we set it lower, it means the more intermediary files will be created, and there is no right answers, right? How big should be your buffer size? It's just about your tasks and amount of your data and amount of your memory. Another optimization trick is group DLT sources into DLT, group DLT resources into DLT source. So as you know, on a high level of hierarchy, DLT has sources, and each source has many sources, resources. And we can run DLT pipeline without grouping resources in one source, and it's not efficient from the DLT side. Next, what we can do? We can specify the number of thread workers. Yeah, we will talk about, I think, a little bit later. And yield pages instead of rows. If we yield items by items, it will take much more time than yielding chunks. What else we can do? We can also customize the size of intermediary files created at the extract stage to control file rotation. By default, DLT creates just one huge file and store all your data, even if it reaches millions. And you need to explicitly set file max items, yeah, with this parameter to any value you need. Let's experiment with these parameters. And first, we consider the worst scenario. We will set buffer size as 1, buffer max item 1. It means that DLT will keep in memory only one item, and then write it down in the file one by one. So it's very inefficient. And also, let me explain the code. It's a function which yields data one by one. We use yield from structure to yield data from a generator one by one. We declared one resource, we declared another resource, and the third one. And running them, so we running each step separately. You can just run, you can use pipeline run method to run all steps all together, or you can run them one by one explicitly, like by pipeline extract, pipeline normalize, or pipeline load. Pipeline run just includes all the steps. In this example, we extract data from these 3 resources as a separate resources. So it means that they are not grouped in one source. And DLT behind the curtains, he creates source for each resource extra. So that's why it's not very efficient. Also, in this example, we use parallelized true argument. It helps DLT to understand, that it needs to be parallelized. But in our case, it won't be parallelized at all. It's going to use one worker per resource because we're declaring each resource separately. And if we run this pipeline, this extract step, we will see that how much time it took, like 53 seconds. It's quite a lot. It's for one step. Just imagine how much time it would take for whole pipeline. Let's try to increase in memory buffer, for example, to 5,000. It means that DLT will keep in memory 5,000 of items before it will be written in intermediary file. And run this extract step. We can see the small improvement. Yeah, it's not 53, it's 46. Not bad. So next, to enable multi-threading, we wrap each source, all resources in one source this way. So we use, as usual, DLT source decorator, define the function, and return all resources. Let's, for now, let's set extract workers to 1 explicitly and check how it goes. Yeah, if we run this step, we can see also small improvement. It's not 46 already; it's 35, so it's good. And we get it only because we combine all resources to one source. Okay, go further and increase the number of workers. And now we can see that the time was decreased significantly. Oh my God, I need a water. And finally, let's apply yield pages instead of rows. As you remember, we yielding items one by one from generator. And in the next example, we will slice all this amount of data to chunks and yield chunks. Let's let's run the pipeline and see. Oh my God, it's amazingly fast. So always yield your data in chunks, not row by row. Go further. Let's discuss normalized step. Usually this step is the most computationally complex. Like it takes a lot of time and resources to go through this stage, because during this stage, DLT checks your data, create schema, does a lot of extra things. And here we can see that on the extract step, DLT moves processes data from source, stored on the local storage. During the normalized place, it takes these intermediary files, extracted files, and send it to the process pool, where each workers process one file. So if we have more files than workers, this will be a queue. So then one file processing by one worker, and it generates normalized files, because our normalized step and extract step, they have different settings for the buffer size. Yeah, for the buffer size and file size. And it means one file, extracted file, normalized file. Oh my God, one extracted file can generate multiple normalized files. So how we can optimize this stage? We can specify the number of process workers, but we can go too far with this, because the process is a little bit more complicated. Also, we can control the in-memory buffer size. We can play with it, not too high, not too low. We also can customize the file size and control file rotation. Let's consider the example. We disable compression. So we're discussing the worst scenario. Setting workers to 1. Actually, by default, it's also 1. And yeah. And files not rotated, it means that it creates one huge file. And see the normalized step. It takes 42 seconds in the worst scenario. If we try to increase the number of workers to 3, yeah, here, it will be much faster, just 7 seconds. Go to load stage. So the load stage works mostly with normalized files. It also processed these files in multiple threads and ingest the data into destination. So the strategy quite the same. And default behavior, the loading happens in 20 threads for each file. Each loading a single file. Yeah. Each thread loading a single file. Yeah. And there's not many things we could optimize, so we can control the number of parallel threads. Let's look how it works with just one worker. It's quite bad. If we increase it, we can see the huge improvement. Also, DLT supports async. So actually, it does quite the same as the previous example. So you can set parallelize equal true or set async. Async doesn't require to parallelize argument at all. So just add async and do your data loading. Let's try to boost our GitHub example. So we'll take vanilla DLT pipeline with all defaults. We do not increase anything, just take as it is. But in this case, we will try to load 7 resources: get issues, stargazers, pools, commits, branches, contributors, and labels. So it's quite a lot of resources. And let's try them to load into DuckDB. We using method run. This method, again, it includes all steps: extract, normalize, and load all together, and check. Yeah, so it takes 35 seconds. So it's not bad. It means that defaults, DLT defaults, they are already good adjusted, but each pipeline requires its improvements. And for example, for this pipeline, we can increase the number of workers for extract step, normalize step. Also, if we set the size for intermediary files, it will enable the file rotations. It means DLT will write your data not in one huge file, but in many different files. So it means DLT can process these files in parallel, because if you have one big file, it will be processed as it is. So we just changed these parameters, and let's run it. We can see it was improved twice, so it works good. So that's it about the performance optimization. If you have any question about it, ask them in Slack. It would be better because all our team could participate in answering. And let's move on to creating custom sources. Okay, a few words about creating custom sources. In the previous part, we learned how to build custom sources with on a low level, with the pure DLT, I would say. Like a few months ago, we released a few helpers REST API client and REST API source, which can help you build these custom sources even faster. So let's start with REST API client. It's a mid-level of, it's a lower. It's not pure DLT, but it's still low-level building blocks for sources. It supports automatic pagination, various authentication mechanisms, and you can easily customize it, everything. We have extensive documentation about it. If you're interested, you should look into. So let's see the GitHub example. As you remember from the previous part, that it's quite easy to create DLT sources, resources with requests library. So you just setting pagination, provide some authentication in get method. Yeah, so you can put here headers or something. Then you declare DLT resource DLT resource. Oh my god, how we call it? No. I just forgot the word. That's fine. I'm getting older. The no. Okay, we're using DLT source to declare DLT source and yield the data. Decorator, yeah. Oh my god. Yeah. So we can do the same with REST API client, but we can avoid this part. Just define the client, provide base URL, authentication type, or you can even skip it because DLT automatically checking if your API has some familiar authentication type and apply it. For example, we don't need to provide authentication type for GitHub because GitHub has bare token authentication. It's super simple, straightforward, and easy to recognize. We declare client, and we can use get method and see what we get. Yeah, so it works perfectly. We're just getting our data from GitHub issues. So in this method, we just provide the path to your endpoint. Let's add pagination. Of course, this example is just a toy example. Nobody uses it, just one page, yeah. Let's add pagination. DLT also handling pagination type recognition. So it's trying to guess what type of pagination you have. Check in. If it works well, it goes on. If not, it's just failing. And you need to add your custom pagination or set it explicitly. So it's also easy to use. Also define client, provide all information about your REST API, and paginate over endpoint. That's it. You can explicitly provide it like this. So DLT has many types of paginators. You can find them at our documentation page. And GitHub has quite also popular type of paginator, header link paginator. So let's try to declare a resource. So because now we're just printing data, yeah, we're not loading it anywhere. And we can declare a source as usually we do with a decorator, with a declaring function, and yielding the data. So we iterate over the data and yield the data. Very simple. And as usual, we just run the pipeline, and it works perfectly. And this client is also quite powerful. You can actually you can add incremental loading as usual because we're declaring resources with pure DLT. So it's all the same, just declaring cursor and provide a parameter we want to use for request. For example, we want to load only data which were updated since some data, yeah. Run the pipeline and see that first run loaded all data, and the second run haven't loaded anything. Yeah, let's add another endpoint. We just also declare another resource, all the same. So the only difference, it's a name. Yeah, it's a name, it's an endpoint name, and that's it. Same way, you can add DLT transformer. So it's same things from the previous part of workshop. And now we start with something more interesting. Let's talk about REST API source. REST API source is a verified source which was built by DLT Hub team. It reuses DLT, or it reuses REST API client and make the process of creating custom sources even easier because you just need to configure the dictionary and run the pipeline. So first we need to initialize this source. Actually, soon we're going to move this source into DLT core because it's became super popular. And so soon you don't need to init, but now you should. So first, initialize the source with the command init, the name of source and destination. Okay, it's done. Let's build the baseline. The only thing we should do is just to fill the dictionary. This is a type dictionary, so it has some required fields, and let's see how we can configure it. First, we need to describe the client. Yeah, what REST API we're gonna request. Set base URL, our old good DLT hub. Then we describing all resources we want to load. It's a list of dicts with the name of resource and path of endpoint. In our case, it's issues. So let's get data from the source. We can see that we import REST API source from the REST API we initialized before, and move and pass this configuration GitHub config into this REST API source function. It creates DLT sources for each endpoint. Yeah, that's actually pretty much what it does. And yeah, let's look at the data. It retrieves data. That's good. Let's go further. Yeah, let's add authentication to this configuration. As in the previous part about REST API client, we discussed that we can have many types of authentication, and DLT can handle many of them. So in our case, we should provide GitHub token for authentication, and we can just set, say, token and the value. That's it. And DLT will check what kind of pagination or what kind of authentication GitHub API has, and where it should put the token. Yeah. And also, you can provide any parameters in the endpoint, and even you can make it incremental. So you just configure the parameter you want to for example, scenes. As you remember, we discussed that scenes returns only data which were updated after the specific date. Yeah, our initial data on the first run, and on the next runs, since the last value. Yeah, you can easily add more endpoints. First, more endpoints like a list of dicts. Yeah, for example, we have first endpoints, issues, add another endpoints, pools. We can add many of them, all of them, doesn't matter. In this case, we had a lot of repetitive information, like params, yeah, and it means we can extract this repetitive data to defaults. So we have resource defaults where we can set primary key, right disposition, and endpoints parameters. You can even use transformers, DLT transformers, with this declarative interface. First, you need to add it as a regular endpoint in the list of dicts, and set the parent endpoint and the path. Path will be variable, which will change based on the parent endpoint information. Yeah, actually, this REST API source is very powerful. You can do a lot of things with it. Sometimes you need to customize parts, for example, authentication or pagination. You also can provide it as a Python objects here. So that's it about REST API source and creating custom sources. So guys, would you use this REST API source for your projects? If yes, tell us in comments. If no, also tell us in comments, and also why. Okay, let's go further. We have in our agenda 2 more topics. Next. Yeah, that's fine. Thank you. Thank you for mentioning. Now we're gonna discuss custom destinations. Yeah. As you remember, you can load your data using DLT to any destination you want, and DLT has some built-in destinations, for example, DuckDB, BigQuery, Snowflake, Postgres, and many more. And recently you asked in comments why we do not have MySQL destination. Yeah, that's a fair question. And what to do if we don't have it? You can, for this purpose, DLT Hub team built DLT Destination Decorator. This decorator enables you to easily capture all data flowing through a pipeline within a single function. This is particularly useful for reverse ETL, where data is sent back to an API. For custom destinations, like sending data to a queue or a database that DLT doesn't natively support, Okay, you get it. Note that in such cases, you'll need to manage migrations manually. And the last case for direct file access. It's allowing you to work with a path to your normalized data files, such as Parquet or JSON lists, which can then be transferred or loaded into a database as needed. For this collab, we will take a top-down approach, starting with an example and then exploring all the intricate functionalities. We will try to load our data from GitHub to Notion. We do not have built-in destination, Notion destination, so let's see how to build it ourselves. Of course, we can move our data directly with the Notion client, but in this case, you won't get any DLT benefits. Let's talk about it a little bit more. So long answer, yeah. If you have a custom destination and want to leverage all of the DLT functionalities, like configurations, schema creation, and everything else, and you can load so you should use the DLT decorator. Oh my god, why I forget this word? Short answer, there's no other way if you want to use custom destination. Let's see how we can do it. First, we're gonna prepare Notion credentials, programmatically create a database for our data, wrap our Notion client with a DLT destination, and run incremental pipeline. First, we're installing DLT and Notion client, set up credentials. You can set up them here if you're working with Colab, but I do not recommend you work in Colab in production, especially just for educational purpose. Then we create a database in our Notion. Yeah, or can do it manually using UI, and we're gonna reuse our GitHub sources. So it's our typical DLT source. We're defining pagination. We setting DLT resource for issues, yield data. So it's all as before, nothing changed. And the only change, we added transformer for issues. I've been trying to get extra information about issues like titles, ID, URL, created. Okay, now it's the most interesting part of this section. We're building Notion destination. It's happening just as you would do that yourself without DLT destination. Yeah, you just define client, you iterating over data, and create pages for each data, for each item. So that's how its approach you would use without DLT, yeah, to load your data to Notion. But if you add DLT decorator, you will get all DLT destination benefits, all functionality. For example, you can provide the configuration here. So let's run the pipeline and see that all data was loaded. And let's see what happened actually here. When we, okay, let me show you how we provide custom destination in our pipeline. So we're defining DLT pipeline as usual, setting pipeline name, and in destination, instead of BigQuery or DuckDB, we're providing our function just like this, and run the pipeline. That's all. During the running, this function will get data from the resource, get issues, and actually from the extract properties, because in this pipeline we run it only for extract properties. It means it will load it only this kind of data. Yeah, title, number, URL, and create it. And yeah, so this function will get data from the resource, and table contains the schema it will create, DLT will create. and credentials. So it's quite simple and easy to use. Feel free to experiment and share your work. That's it about custom destinations. And if you have any questions about it, also ask them freely, preferably in Slack. I'm asking to move all your questions to Slack because that's a more chance that they will be answered. It's easy to answer, it's easy to track because each question will have a thread and we can have discussion here. So go further. We have 15 minutes. Let's start with deployment part. So I'm gonna share the entire screen because I need to switch between screens. So there is a README of our DLT education repository. And at the end of this file, you can find deployment section. And the link leads to the folder, which contains all 3 deployment methods I'm gonna discuss today. We start with Lambda function. Well, I'll try to increase it. No. Okay. Is it big enough? If not, let me know. Okay, AWS Lambda is a serverless compute service that lets you run code without provisioning or managing servers. It's quite convenient if you want to run your pipeline and do not care about how to deploy it. Let's go through the process together. I'm going to show you how to do that. What we're going to do, we're going to create Lambda function, add DLT pipeline script, configure the function, create a layer, and test it. I prepared a GitHub pipeline. So it's our regular GitHub example, GitHub issues. I just copy-pasted it under the function definition with name Lambda handler. Just copy it and go to AWS service. I'm going to use AWS console to make it more, clear. So under services, go to compute, Lambda. Shit. Yeah, go to Lambda, create function. Let's set some function name, workshop function. Pick the runtime. In our case, it's going to be Python 3.12. Pick architecture ARM64. In my case, because I have ARM64 architecture, and create the function. It takes a little time, and let's put our pipeline code right here in editor. Let's just copy paste. We can see from previous example that all Lambda functions should have Lambda handler name. You can change it actually, but in our case we won't change it. So let's keep it like this. By default, Lambda function will try to find Lambda handler name. Just copy paste it here and save the changes, pressing deploy. I would try to test it, but I know that first, before you run the pipeline, you need to install DLT package and DuckDB package, because otherwise AWS will try to run it in the empty environment just with a Python. That's it. And now it's a little bit tricky to add these packages here. For Lambda functions, they use layers. You can add a layer, but first we need to create one. Let's try to create a layer. Go to Lambda, pick layers, create layer, set a name, workshop layer, upload a zip file, yeah, and pick configuration. Upload a zip file. That's interesting step we need to go through right now together. And let's do that. I'm gonna follow the instruction I prepared. So we edit, create a layer with dependencies. I have, if you try to run this pipeline without packages, you will get an error message like no module named was found. Yeah. And unfortunately, I have MacBook. No, unfortunately, yeah, but AWS doesn't work with MacBook environment. If I installing DLT and DuckDB on my MacBook laptop, it would be slightly different than if I install it to Linux. That's actually DLT works for if I install it on Mac and trying to run it on Linux, it will work. But DuckDB really sensitive to architecture. It means I have to imitate that I have Linux with Docker. So first we pull the image with Linux with architecture RM64. You can pick any other. Then you create a container. I actually already created one. Let's create another one. I named it Lambda Linux RM64 and set the image and Linux RM64 and configuration like Python 3.12. Let's run it. With this IT key, we can go into this container interactively and do stuff. For example, we can install inside of this container. We can create folders, for example, or install packages in this folder. Yeah. The same way we install DuckDB in the same Python folder. And let's see if we get it. Yeah, we can see DLT and DuckDB were installed as some extra dependencies. Let's exit. Now we have to copy these generated files with installed packages to my local machine to the Python folder. It's important that your folder names Python because Lambda function will understand that in this folder you keep all packages, installed packages. So the Python name is very important. Let's copy it. It's here. We can say it. Okay, in temp file, in temp folder. What is next? Let's zip it because it's a requirement from Lambda function and call it Lambda layer RM64 zip. Okay, we can see that our zip file was created. Let's move it to our Lambda function as a layer. Picking architecture, runtime, it should be the same as your configuration of your Lambda function. Create it. Okay, it takes a while. Let's wait. And let's add this layer. The layer was successfully created. Let's add it to our Lambda function. Add a layer. We see the runtime, architecture, and it should be the same as there. At so now we can try and test it. So installed on packages. Let's create a test event. It will send event JSON. We do not care what kind of JSON it's going to be. Let's send this one because we actually do not work with event. As you can see here, event and context, we do not touch them. So it doesn't mean what kind of event it will be. Let's save and test. Oh no, it's time out. In 3 seconds. How to fix it? Let's go to configuration, set timeout. I don't know, like 5 minutes. And as we are here, let's increase the memory to 500 and save. Let's try to test the pipeline again. It will take a while. Okay. Oh, no, yeah, it's failed again. Why? As we can see that the home directory actually has strict access, read only. And DLT usually creates a lot of metadata and intermediary files in a home directory. But we can change the settings. Go to configurations, environment variables, edit, add environment variable, and change the data directory with Lambda function and change it to temporary folder, because it's the only folder we can write into on AWS and Lambda function. And also we should change the DuckDB credentials, because it's also will try to create a dump in outside of temp folder. And let's set it explicitly that we want to save our dumps in temp folder. Save it. Let's go to code and try to test it again. Okay, it's not failing. That's nice. And yeah, response and status success. That's what we return in case the function worked correctly. So that's it about Lambda function. I hope it was useful. Let's discuss one of your favorite orchestrator. It's Duckster. How to run your pipeline with Duckster. Let's create another temporary folder and go through the README. Okay, so Duckster, it's a orchestrator designed for developing and maintaining data assets, such as tables, datasets, machine learning models, and reports, or data pipelines. Yeah, let's start with creating the Duckster project. First, we need to install Duckster. As I mentioned before, Duckster has built-in integration with DLT, and we need to install extra package, Duckster Embedded ELT. So let's install it, and then we can use Duckster project scaffold command to create Duckster project structure. Okay, we can, of course, skip it and create files ourselves, but why we should do that, yeah? So it was successfully created. You can see it in my temporary folder. And the project tree looks the next way. We have GitHub source folder with 2 scripts for assets and for definitions. Let's add also another script here. Let's add the DLT pipeline to this folder. I would create it directly here. Yeah. Python GitHub pipeline and put some pipeline. For example, I created it already. You can find it in our repository, but I wanted to go through it again with you in real life. And so, yeah, I just copy-pasted my pipeline into GitHub source folder, into GitHub pipeline script. So this pipeline, all the same DLT resource, same GitHub issues, and the only difference that I wrap it in DLT source, because Duckster DLT integration supports only DLT sources. So you should wrap it in source. Actually, you always should do. And okay, go further. Let's create a DLT assets. Go to assets script. It's empty. It was automatically generated by Duckster command. And we're going to use DLT assets decorator, which we imported from Duckster Embedded ETL ELT package. Here we provide DLT source. I just imported DLT hub pipeline script as a module and imported DLT hub source, this one, as usual. And yeah, just pass it to DLT source as a source. Define your DLT pipeline configuration, set a pipeline name, dataset name, destination, and some extra arguments. What else is important here? I think that's it. Let's copy paste it to our assets and go to definitions. So this tab enables Duckster to load everything we defined. So we're gonna import our assets from the assets script, assets file. Also, we should define Duckster DLT resource, because we need to provide in definitions assets and resources. In this case, we're gonna tell this Duckster DLT resource, it contains all the logic of DLT pipeline creation. So it sets pipeline, it's run it, and so on. Let's just copy it here. Yeah, all assets, that's everything we have in this file. So that's our DLT asset. So let's copy it to definitions. We already have some, but let's place it with our DLT resource. So now we're going to try to run it locally. First, we need to install the all dependencies. Because I need to go. I need to go to the GitHub source folder here because my project Stonewall is here. So let's go hub source and run it again. Okay, everything is installed, and let's run the project. Let's look at the UI. So now we can see Duckster UI, which I will locally run. You can see our project, DLT Hub source. It was loaded, but the data wasn't loaded yet. To load your data, just go to Assets and pick the sources you want to materialize. And let's run it. So materializing, it means process is going. So data is loading. Okay, it's done. What we can see here, yeah, we can see view lineage. You can see how it actually looks like. And in our project, we can see the DuckDB dump. It was created. It means the data was loaded. Also, you can see the logs in your command line. Yeah, so extract stage, normalize stage, load stage, and load info. So it was loaded successfully. That's it about Duckster right now. Of course, you can deploy it on Duckster Cloud if you don't want to deploy it yourself on a server. And let's go to Airflow. And I also prepared description for Airflow process. First, I wanted to show you how to prepare Airflow DAG and how to deploy it on GCP, Google Cloud Composer. But I realized that it will take a lot of time, and probably we'll have another workshop for deploying things on Google Cloud Composer. And let's first understand how DLT works with Airflow. So DLT has extra commands for deploying. It calls deploy command. And to make it work, you should install some extra dependencies. Okay, then we creating our DLT pipeline. Guess what? It's going to be DLT Hub or GitHub source again. I prepared the script here. You can find it in our repository. Just let's copy paste it and move it to new directory. Call it GitHub pipeline. Just copy paste our GitHub pipeline here. And okay, look what is next. First, we need to ensure that our pipeline works correctly. Let's run it. Because it's called GitHub source. Let's run GitHub pipeline.py. And yeah, it works. Why we need to run it before creating Airflow Duck? Because DLT deploy command, it uses GitHub pipeline metadata for Duck creation, and gives you some useful tips. Okay, it was successfully loaded. Let's apply DLT deploy command. Yeah. Deploy GitHub pipeline, and we're gonna have extra comment Airflow Composer. We have another helpers for deployment, for example, for GitHub Actions. I not talking about GitHub Actions during this workshop because it's so easy. You can do it yourself. Just visit our documentation and have fun. So you can see what it's saying. It actually, this command looking for a template for Airflow Duck. Then it creates folders like build folder, you can see it here, and Ducks folder, you can see it here. And it always creates it in the root of your project. So what else? It gives you a small instruction. What is next? Yeah. So you need to import your sources in Duck GitHub issues. It was automatically created. Let's look into it. What inside? We can see that there is a typical Airflow Duck was created with a Duck decorator with some default arguments. And you can see some weird class pipeline task group. What does it mean? Yeah, it's actually the main helper, DLT helper for Airflow. It helps you to decompose your tasks. It supports different decompose strategies like serialize or parallelize. Serialize, parallel, isolated. And so it helps you create tasks and based on DLT sources and resources. Of course, you can skip usage of pipeline task group and do it yourself. If you're big pro in Airflow, of course, you can do it yourself because DLT is just a Python library. And every helpers, they are just helpers. So it says we need to import our source from DLT, GitHub pipeline. So we first need to add some and another one. And try to import it. So we start with temp folder, then go to Airflow workshop and import our GitHub source from GitHub pipeline. Of course, we have to provide the source into tasks add run method. And that's it. You can extra configure it. You can change parameters. You can change how to run it. Now it's by default, it's daily. There's You can change the composition strategy. Yeah, you can change a lot of things. And let's rename this function. Yeah, from load data to load workshop data. And try to run it. Okay. So we went through step 5. We modified Doc. We changed it. So let's try to test it. First, I want to change Airflow core DAX folder environment variable because I don't want to move my DAG into home Airflow directory. So I just change it to my current project directory. First, I think, no, that's my, yeah. First, I think I need to clean my Airflow database because I already played with it. Actually, I can delete everything in here. And try to run Airflow standalone. Okay, I use standalone only for testing, so it's quite a convenient command to test your DAGs. So you can see my password here. I run it locally, so I can show you my password. And go to a local host 80. Sign in and so yeah. Okay, it works. So now we try to find our DAG. Yeah, it's here, load workshop data. Let's look at this. Yeah, we can enable it. Okay, let's do that. Let's look in the graph. We can see that it was decomposed, but yeah, we have just one source resource in here, get issues. It would be more interested if I would use few resources, but I forgot about it. So let's try to run the pipeline, trigger DAG, and see how it goes. It's running. It's success. So that's it about Airflow. And if you're interested how to deploy it with Google Composer, we have really extensive documentation about it. You can go through these 2 pages. First, how to configure your Composer, and then how to run your pipeline on it. Oh. So that's it. Thank you so much for your attention. I hope you liked it. If not, please tell us. If you like it, also tell us. And we're always open for feedback. And I will send you feedback form in Slack channel. And see you next month, probably.